Find a possible solution for f of x, given that f of x is the integral of 1 over quantity square root of 16 minus x squared. Okay? Green? Yeah, green's good. So this is going to be a trigonometric substitution. Probably one of the more difficult types of integral problems you'll find on the AP exam. So what you look here, and the kind of the mnemonic that I use is if the negative is with the x, then that's going to be sine, because the sine is with the x. If the negative is with some sort of constant, I'll call it a squared, then you're going to use secant. And if there's no square root at all, and you have some sort of like a squared plus x squared, then you're going to go tangent. So for this one, the sine is with the x, so we're going to use sine. And we're going to say that x equals 4 sine of u squared. 4 sine of u. It'll get squared later. And the idea here then is this 4 right there, when we square it, we want it to be the same as this over here. So when that 4 gets squared, we'll have 16 minus 16 sine squared. And a couple of things, if you do a whole bunch of these, you kind of get, oh, okay, here's the pattern. And so I'm going to find a couple of things right off the bat before I do the substitution. So I'm going to be like, x squared equals 16 sine squared of u. This also seems a little bit backwards from normal, because normally you say u equals this. With inverse trigonometric substitutions, inverse trig integrals, the u then will be x equals something involving u. All right, but then we're also going to want to solve for u, and so we'd have, let's see if I can do this. So this would be u equals arcsine of x over 4. So you take the 4, move it over, take the arcsine to both sides, and you get u equals arcsine of x over 4. Okay? Now we should probably do the derivative. So find the derivative of both sides. Dx equals 4. Derivative of sine is cosine of u. 4 sine cosine. Yep. And then du. So you can think of that as the chain rule, where take the derivative of the interior. Interior is u. Derivative of u will be du. Okay? Okay. Whoop. Blue. Think. All right. And so I'll look up here, do some substitutions, try and get everything in my field of view. So this will be integral 1 over 16 minus x squared, which is 16 sine squared of u, square rooted, and then multiplied by dx in the top, which will be 4. I know that's terrible boardsmanship, but it was darn convenient. Du, okay? So now I'm going to rewrite this once, at least once. So we'll have square root of 16 times the square root of 1 minus sine squared of u all over 4 cosine of u? Is that cosine of u? Yeah, cosine of u. Du. I know that u is terrible. It's okay. So the square root of 16 is 4, which will cancel the 4 up top. This right there, 1 minus sine squared. So you have sine squared plus cosine squared equals 1. That's the Pythagorean theorem. So 1 minus sine squared equals cosine squared. So what we're left with then is integral of cosine of u du all over cosine squared of u square rooted. One more time, we have cosine of u over cosine of u du. Cancel, cancel. We're left with integral du, which will give us just a constant. I'm going to call it 1. Really, we should probably do c, but that's okay. We'll worry about that later. No, that's u. Whoop, u. U plus c. And then we're going to substitute back in for what u is, and we know what u is from over here. So we're left with equals arcsine of x over 4. Move this over here. I only got one part of the equals, now it looks like a negative. Ambiguous. Get rid of that guy. Okay. And right here, top. This will be the answer. And your first thought process was, oh, that worked out almost magically. Maybe I can just memorize the integral formula and I can just skip all the intermediary process, skip to the end. You could. I would not recommend it. If you're the kind of person that's good at memorizing, then maybe go for it. Go for it. Not bad. For me, memory is terrible. Memory of a goldfish. Have I said that before? I think I have. I don't remember. That's okay. The idea, though, is you do probably have time to go through the process, and you're less likely to make a mistake, probably, if you go through the process. So I would recommend actually going through the process. And these questions are asked rarely enough. You might get one, possibly two inverse trigonometric questions on an AP exam. So for one or two questions, it's not really worth doing the effort of memorizing all the formulas. You're more likely to see these kind of questions in a first year, actually second semester calculus course at a university. But really, all that I'd recommend memorizing is just these mnemonics here. See the negative x squared, probably sine. Negative constant squared, probably secant. A squared plus x squared, that's going to be your tangent. And you can kind of figure those out yourself and kind of derive them. But you're almost better off just memorizing this and then just going with the formulas. So that's how you approach this problem. And, arcsine. Convenient title. That's how you approach this problem. And wish you the best of luck. See you in the next one.